The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, and for number 5, we're just doing another series to see if it converges and explain by which test. So we have the series n equals 1 to infinity. So the top, that's a product of odd numbers up to 2n minus 1. There's no real better way to write that than the way it's written there. And on the bottom we have 2n to the n. So you have a couple conflicting things that might confuse you on which test to choose. You do have part of it raised to the nth power, so you might think root test. In that case, that would actually make it more difficult. It might be possible, but it's definitely more difficult. In this case, you definitely want to use the ratio test. That's going to be the easiest way to do it. Two things, mainly because, first of all, it's a fraction. Right away leads a little bit to the ratio test. Secondly, you have a, well, in this case, you have a semi-factorial thing. You're multiplying odds only. But you have an infinite product. That usually lends itself to ratio test as well. So if we do our ratio test, absolute value of a sub n plus 1 over a sub n. So when we do n plus 1 here, this product is just going to get an extra term added to it. If you think about it, if you plug in n plus 1 instead of n, you're going to get 2n plus 2 minus 1, which gives you 2n plus 1. But you're also going to have the term that was before it, which we just said, or what is named here as 2n minus 1. So that just adds another term to that product, which would make sense. As you go up 1, you're just putting another odd number onto the end of it. And when we plug n plus 1 in here, it's very important that you do this correctly. You have 2 times n plus 1 instead of n, and now it's raised to the n plus 1 power also. Alright, so we're multiplying that by the reciprocal of our original series. So we have 2n to the n, and we have the product that stops at 2n minus 1. Alright, so before we do the limit as n goes to infinity, what you have to do for ratio test, let's see what cancels out. All of these odd numbers cancel out. You just have one extra one on the n plus 1 sequence. So far, it doesn't look like anything else cancels out there, so let's rewrite it. We have 2n plus 1, and we have a 2n to the n on the numerator. For the denominator, let's expand this. So we have 2n plus 2 raised to the n plus 1 power. We need to distribute that 2 inside. So we need to do the limit as n goes to infinity of this and see what happens. Remember that the ratio test is convergent for less than 1, divergent for greater than 1, 1 is inconclusive. So this one is going to take a little bit of creativity to try to help you find the limit here. What you should be thinking, and this is going to happen a lot in ratio test problems, is that if you have powers of n, or one of n plus 1 and one of n, you want to make them both n so you can combine that into one term, meaning you need to rewrite this as an extra term times it to the n power. So what we're going to do is write the top the same way, but on the bottom we're going to take one of the 2n plus 2's out and then write 2n plus 2 to the n. So that's the exact same thing as that. I just took one of the extra 2n plus 2's and separated it from the 1 to the n power. And like I said, the reason you want to do that is you want to get multiple things with the same power. So we can do something very similar to the previous time we used ratio tests on this exam, which is now separate this product into two separate ones. So we have 2n plus 1 over 2n plus 2. We can deal with that separately. And we have 2n over 2n plus 2 to the n, and we can deal with that separately. So what I did here was with the two things that were to the n power, I combined it into one fraction. We're doing the limit as n goes to infinity of this. Well, This first term, same degree, same coefficient, limit of m goes to infinity of this is 1. So all we have is this term. Now this one's not immediately obvious, because if you have what looks like 1 to the infinity power, that is not a conclusive limit there. So it's an indeterminate form if you're thinking about it from Calc 1. What we can do, though, is that if this was 1 term on the denominator and 2 terms on the numerator instead, we would be able to separate this in terms of fractions, and there was an example in your book where this ended up being something related to e, and that's what's going to happen here also. So what we're going to do is say that this is the same thing as if we had 1 over the reciprocal of that. Okay, so because this part was 1, we can forget about it. This is the same thing as the reciprocal of the reciprocal. That gets you back to your own thing. But you want to do this because now this is easier to deal with than the one here. So what I'm getting at is we can split this up. This is 2n over 2n plus 2 over 2n to the n. 2n over 2n is 1. 2 over 2n is 1 over n. That n stays there. So we have a much more simplified form. And 1 plus 1 over n to the n, as n goes to infinity, is the definition of the number e. So, at the end here, we get that that limit is actually equal to 1 over e. E is a number 2.7-ish, it's bigger than 1. All that matters is you're trying to figure out how does that number relate to 1, because if it's less than 1, ratio test shows it converges. 1 over e is definitely less than 1. So this is going to converge by the ratio test. Remember, ratio test, make sure you get something other than 1, because if it's 1, it's inconclusive. But you had to do a bit of finagling here with this terms of this to get the limit to work out nicely. You should expect that when you have things raised to the n power and you use the ratio test, if they don't cancel out nicely and you're left with stuff like this, it's probably going to turn into something with the e form.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.